when AC is off, when AC is on, and also 22 degrees threshold when AC is turned off. And then finally, we calculate the average temperature over 10 cycles. Okay, so we are required to write Python code that meets the above requirements. In addition, we need to explain how the temperature sensor, IoT device, and AC unit interact in the system. Okay, let's work on that. Let's work on the simulation. Okay, let me share our online platform, Google Colab, and then start working on this. Okay, so you can search for colab.google if you have internet, and then you can click on new notebook, and then you get a new IDE notebook that we can use for our Python coding. Okay, it is here, so we can begin. Remember, let me try to either maximize this so that we are able to see clearly. Yes, I think that's good enough. Remember, we start by importing the modules, import modules that we are going to use. And we said we are going to use random so that we randomly generate temperatures from a given range. And also we said we need to use time so that we sleep within a few seconds and then wake up and read the temperature again so that we simulate the real world scenario for temperature sensing. And then for plotting, we need to use the matplot lib. This library, it will help us. Yes, just like this, we can accept this code. Yes, like that. And then after that, we can create our classes. Our temperature sensor class. Okay, we have used the class and set temperature. We can also use temperature sensor. Okay, and then we can okay, let us create our own code. We say define, initialize the init underscore self, bracket self, and then we give the minimum temp and max temp, like that. Okay, and then we initialize them like this. Mean we did this last week, so it shouldn't be a problem for now. Self.max temp is equal to max underscore temp. Perfect. And then we define another method for reading the temperature. Read temperature. You can go select here, and then we say for reading temperature, first and foremost, we just return temperature read. We can return, but we want to round off the temperature. Yes, let us accept this code and then look at it. Yes, we use the round function so that we can specify the number of decimal places we want. Okay, like this, random.uniform, then we give the minimum temperature and maximum temperature, and then the two, meaning that we need to display this temperature in 2 decimal places. Okay, that's done. And then we can now create our IoT device class. Okay, class. Wow, it gives us some basic code to start with. You can click on it, and then we accept. You see, class IoT device. Initialize it with. We can call this one device ID or device name. Then temperature sensor. We can leave it like this. Self.name is equal to device name. Underscore name is equal to device name. Okay, device name, and also self.temperature sensor is equal to temperature sensor, like that. And then here we want to, let us write our own code. We want to display the temperature. We can use the display temperature. Yeah, display temperature. Oh, we can say display temperature data. Then we give it self. Okay, And then here we can first of all capture that temperature. You can say temperature red. Temperature red is equal to self. Yes, let us accept this is equal to self dot temperature sensor here dot read temperature here, which is okay. And then we can print. You can print the device name. Okay, here we can say device name. Give it a name and then say you can put a bar here separate so that you get temperature temperature reading. Yeah, like that. And then we can return temperature red. Just return temperature red. Yes, look at this. Return temperature red. Let me return temperature red. Okay, like that. So that is done. That is done. Display our temperature, and then we can work on the SC unit class. SC unit class. Yes, SC unit class. Okay, so we say class SC unit. Okay, we accept it. SC unit, and then say for the SC unit class, we need to also initialize. We can initialize init. Okay, let us first accept this one. We need self SC name and also the room where we want to monitor the temperature. Self.sc name is equal to name, and then we can say self.room is equal to room, like that. This one we shall thingy later. And then here we can set the AC. We can set the AC. We can set self dot is on, is AC on. Okay, we can make it default false. Okay, make it so false. Okay, and then we define we define now AC on, turning AC on, turn on. Okay, we can accept. This is self. Okay, self, and then let us create enough space here. So here to turn off, we just call the self dot sc dot is on. We make it true. Yes, we make it true, and then print. We print that sc. Yes, the AC name in a room is turned on. Yes, perfect. And also this turn off, okay, turn off method, which is also correct. Okay, like that. We accept that code, and then we manage the AC. You can define manage AC function. Okay, give it self, and also give it the current temperature. To manage. So based on the current temperature, it can decide whether to turn on AC or turn off AC. And then here we say if current temperature is greater than, they said 28, is greater than 28, for example, we turn on AC. Yes, you can accept that. Whereas if current is less or equal to, they give us 22 degrees, we turn off AC. Yes, as simple as that. We turn off AC, as simple as that. We are done with that. And then we can now create our main simulation. Main simulation function, whereby we can define simulate temperature monitor, and then we give it the number of cycles. We want to simulate how many cycles. Okay, and then we can say temperature sensor, temperature that is sensed. For temperature sensor, we can give it the temperature. Yes, let us accept that. And here we say this was our minimum temp equaling to that. And here our max temp equaling to that. Okay. And then we can say, now there we can create an IoT device variable. And we say this is equal to IoT device. Let us first accept this IoT device. Yes, device name. Device name, we can give it a name. We say maybe sensor 01 underscore 01. Okay, then temperature sensor is equal to this temperature sensor. Yes, we accept that. Okay, accept that. And then we enter. Okay, and then the AC unit. Let's first of all accept this one and modify the AC unit is called AC name. You can give a name here. Just close there. Okay, and give the name. You can say AC 001. Okay, you give it a name and also give the room name. And here you can say maybe it is the living room, as it's suggested, living room. Okay, that's it. And then we can create our temperature readings. Okay, where they will be stored, we can create an empty variable or basket where we shall be storing our temperature readings. Okay, initially it is empty, and then we can create a for loop. We say for I in range. Okay, yes, in range cycles. Yes, it had suggested in cycles. Yes, in cycles we can accept this code and then try to modify it. Current temperature is equal to IoT device dot display. Yes, correct. AC unit dot manage. We manage the current temperature, correct. Temperature readings. We append the current temperature, correct, so that we keep adding to our basket, and then we sleep for 5 seconds. We wait between readings, and then eventually we return the temperature readings. We return a basket full of what? Full of temperature readings. Okay, so that is done. And then we can create now the function to calculate the average. Function to calculate average temperature. And we can say define. Wow, let us accept this one. Yes, it has given us the clear code, calculate average temperature, we give it temperature readings. Okay, and then we return. We said total temperature is equal to sum of temperatures. Yes, average temperature is equal to total temperature divided by length. We can shorten the code so that we return. Let us shorten the what? The code. We just write one line of code. We say return. Yes, like this. Return the sum of temperature readings. These ones we add all of them and then divide by the length, by how many of them. Okay, and then we return that temperature. We shall be good to go. And then finally we can create our simulation loop function. No, function to plot. We can plot function to plot the temperature data, temperature readings. Okay, and here we shall define. Oh, it has given us some code to begin with. You can accept and then say define plot temperature. Okay, and then we give it temperature readings, and also we give it cycles as well. Yes, temperature readings and cycles. How many cycles? And then purity.plot. We want to plot. Yeah, it will work, but we can plot from a range. Okay, we can plot from a range of values. We need to plot. We can plot from 0 to cycles. Okay, and then give it temperature readings. Yes, like this. accept temperature reading, and then we put a marker. In our task, they said we put a marker for that temperature. When we plot, we put a marker equaling to, let's put a 0 like this, and O, so that we clearly see the values. And then, yeah, just like that, grid on. These are cycles. We can say cycles, for example. And here, temperature in degrees Celsius. Yes, tied to temperature readings. Over 10 cycles, you can mention them. Over 10 cycles. Okay. And then we can PLT dot, and I said we put X H line, yes, like this. Let me accept this one, whereby we mark where the anomalies are, especially 28 degrees Celsius, where we turn our AC on. We can use B for blue line and then dotted line, and then we can also label and say, yes, you can accept here and say 28 degrees, yes, 28 degrees Celsius. That is 28 degrees Celsius threshold. You can say threshold temp 28 degrees Celsius, and also this line, which is okay. Blue, we can make this green, okay, and say label threshold temp equaling to, oh, we can say AC off here, AC off here, AC on, AC on, just like that, so that we see those lines clearly. Then we can have a legend there, okay, and then we show the temperature, okay, graph, just like that. So we are done with that, and then we can say we define another function to run the simulation. Okay, function to run the simulation. Okay, function to run the simulation. So here we define run simulation. Let us accept this code here. Run simulation. Yes. Cycles. We give the number of cycles. We said 10. Oh wow! Temperature readings. Simulate temperature monitor. Oh, wow! It has given us a clear code, and then calculate the average temperature according to that, and then plot temperature readings. Okay. Yeah, like that. I guess we are done. And then we can print. We need to print this average temperature. Here. We print, yes. Oh, wow, this AI Wanang is very good. It knows that we want to print the average temperature here, like this, before we plot. And then we plot a graph like that. And then after that, here we run the simulation by putting our function run simulation. Yes, run simulation here. Yes, good. So we are good to go. We are good to go. If you don't have any errors, you should be able to run this and it works. Okay, let me click run. And then we see this is a monitor here. I want to monitor the temperatures, calculate the average temperature, and also be able to plot and visualize the data. Let me see, there's some error, terminated the string, it will detected at line 74. Yes, yes, it's good to have errors and we'll be able to, yes, here you can see we did cross this one here. Perfect, you can cross that line, okay? And then run again. And then we monitor here. We have another error. We didn't save. Label is equal to AC unit. Let me see, there's another error here. the same line. Okay, this is label. Here we didn't put that. Close the quotation. Okay, perfect. First, you can clear this selected output and then run our code again. There's another error, was never closed. Yes, the grid. Oh, wow, we have some interesting errors here. We are missing some here. You see, with now AI accepting the code, we can miss some of these. But it's good to have some of these errors so that you learn how to code properly. Okay, we can clear this selected output and then run our code again. Perfect. I think now it is working. Device name, sensor 1, temperature is 27.87 degrees Celsius. Temperature is 28. Now this is interesting because it is above 28 and the AC should turn on. Wow, it is interesting. You see AC in living room is turned on. We continue monitoring the temperature, 23, 28. Now again, is above the threshold. AC should turn on. Continue monitoring the temperature. Now, interestingly, this one is below the 22 degrees, where the AC should turn off. Wow, perfect. Our code is running perfectly well. We continue monitoring the temperature until we reach 10 cycles, and then should be able to calculate the average temperature and then be able to plot. Wow. See that? Average temperature 26.162 degrees Celsius, and this is our temperature. This is our plot. Let me minimize this one so that you can see clearly. Okay, so that you can see clearly. Wow, you see that? This is our plot with the heading temperature readings over 10 cycles and with our threshold of 28 degrees so that you can see which temperatures are above the threshold where AC turns on, okay, and the temperature below which the AC turns off. This is 22 degrees, so there was only one reading where the temperature needed to, where the AC needed to be turned off. Temperature below 22 degrees Celsius. Remember, our range is from 20 to 35 degrees Celsius. Okay. Wow, this is interesting. Okay. So this is it. You can see clearly the labels, the X labels and the Y labels, and also these dotted lines that we labeled AC on 28 degrees Celsius. This one, and also AC off at 22 degrees Celsius. You see? And this is our output. The 10 readings, remember we said 10 cycles, okay? And this is a complete code like this. Wow, so I encourage you guys to continue practicing.